So, let's take a look at our first construction. Given segment AB shown below, do the following. All right, so we're just going to do step-by-step, follow the direction kind of stuff on here. Draw a circle whose center is at A and whose radius is equal to the length of AB. All right, well, I've got my handy-dandy electronic compass here. Now, on all compasses, there are two ends, right? There's the pointy end, and there's the pencil end. The pointy end will always go at the center of the circle, and the width of the compass always represents the radius of the circle. And remember, then all points on the circle will be the same distance from the center as all other points. So specifically, what I want to do is I want to put the center of the circle at point A as much as I can. I want to make the radius of the circle equal to the length of AB, and then I will draw my circle. Okay, so simple enough. Okay, not perfect, but simple enough. Do the same, but with the center at B and the same radius. Now that can be tricky because you might want to fold up your compass really fast, right? As much as you can, when you're using the same radius more than once, you want to keep the compass at that setting. So I'm going to leave it just like that. I'm going to switch it around so my pointy end is right here. And then I will draw, whoops, and of course I lost it. That was unfortunate. But I'll draw my circle around like that, collapse my compass some, and put it off to the side. Okay, now keep in mind again, all the points on this circle lie a distance of AB away from A, and all the points on this circle, wherever that circle is, lie a distance of AB away from B. Okay? Letter C says, mark one of the intersection points of the two circles. One of the intersection points of the two circles, label this as point C. So I'll label that one. Okay? Draw segments AC and BC. Okay, well, let's take our straight edge out. That's simple enough. I will connect it to point A, rotate it up, and then do my best to draw that line segment in. Likewise, now I'll put it over at B. Again, draw the segment in, and get rid of my ruler. Okay, finally, explain why ABC, triangle ABC, must be equilateral. All right? Now again, we've actually done this construction, but it was way, way back in Unit 1. So let's think about that explanation. Take a moment and write down what you can. All right, let's do it. Maybe I'll just write the explanation up here. Okay. Because point C lies on both circles, it is a distance of AB away from both A and B. So all three sides have the same, sorry about that, length, right? All three sides have the same length. Now, a couple comments about this particular construction, or about constructions in general. You know, you probably noticed, right, this one circle, the first one I drew, slipped a little bit, didn't quite go through B, right? Possibly when I drew the line segments, I actually did a decent job on this one, but maybe they'd miss C by a little bit. Your constructions don't have to be perfect, right? You might be dealing with a compass whose pencil is dull, whose tip isn't, you know, like very well put in, right? Constructions can be quite challenging mechanically. We're not looking for perfection, we're looking for understanding. And keep that in mind all the time when you're doing constructions. It's another reason why you should never erase your construction marks. because it's in the construction marks themselves that teachers or whoever is looking at your standardized exam or test, it's through those marks that they will know whether or not you understand how to do the construction. All right? But constructing an equilateral triangle, which is the first one that we're doing, and it's this one, is actually quite easy. And again, you did that back in Unit 1. Let's go on and